Hey guys, welcome to this session. Now, before we start off with the session, just give me a confirmation if you guys can see my screen and if you guys can hear me. And if all is well, we'll just start off with the session. Also, let's just wait for other folks to join in. So, in the meanwhile, I'd like to inform that we have launched a completely free learning platform called Great Learning Academy, where we have almost 100 courses with respect to artificial intelligence, data science, machine learning, digital marketing, and a lot more. And all of these courses have been taught by industry experts who have almost 10 years of experience and they've got their PhDs or master's degrees from Ivy League schools such as Stanford, and you have IITs and NITs in India. And once you complete these courses, you will get a course completion certificate, which you can go ahead and add onto your LinkedIn profile or onto your resume. So you'll find the link for GLA in the chat. And also, if you want to learn through an app, we have the Great Learning Academy app, and you'll also find the link for that in the chat as well. Now, to the folks who are new to our channel, I'd like to inform that we conduct these live sessions on a regular basis. We conduct almost 2 to 3 live sessions every single day, and we ensure that your lockdown is as productive as possible. So if you guys just go ahead and hit the subscribe button and click on the bell icon, it will encourage us to come up with more such live sessions to ensure that your learning never stops. Now, I see a lot of yeses from your side, so everything is fine. So let's just go ahead and start off with the session. So in today's session, we'll have a quick introduction to machine learning, and then we'll have a demo on sentiment analysis with Amazon reviews. So let's start by understanding the concept of machine learning. Now, guys, tell me what exactly is over here. What do you see in this slide? It's a pen, isn't it? Now, how do you know this actually is a pen? Now, what I'll do is I'll go to the next slide, and could you guys tell me what is this? Well, this again is a pen. And this, well, this too is a pen. Now, all of these are pens, and your brain has immediately recognized that all of these are pens. But how did this happen? Well, this is how our brain works. So, when you're in kindergarten, let's say you are told by your kindergarten teacher or your parents that this is a pen, and your brain learned that whatever looks like this is actually a pen. And that is how our brain functions. But what about a machine? If I take all of these images of pens and I feed them to a machine, we'll be able to identify that this is actually the image of a pen. So this is where machine learning comes in. So the concept of machine learning is pretty much similar to how our brain works. So what we're going to do is we'll take all of these images of the pen and we'll continually feed them to this machine, and it will learn all the features associated with these pens. So this is what is known as feature extraction. So here it will learn that a pen has a cylindrical shape. It probably would have a nib with the help of which we write. It might have a sort of a stub over here, and these are different properties which it will learn. Now this is known as the training phase, and once the training is done, we will give it a new object to determine how much it has learned, and this is known as the testing phase. So here we give this laptop or the machine a new image, and we're trying to determine whether it is able to identify this object as a pen or not. And if it is able to identify that, then the training has been successful. On the other hand, if it is not able to do it, then it would mean that it has to be trained more. So what happens in machine learning is basically once we go ahead and train the machine learning algorithm, and once the training is done, we give it new data or test data to determine how much it has learned. So this is the underlying concept of machine learning. Now let me know if everything is clear till now and if you have any doubts. So now that we know what exactly is machine learning, we will go ahead and look at the categories of machine learning. So machine learning can be broadly divided into supervised learning and unsupervised learning. Now we also have something known as reinforcement learning, but that is something which we'll be covering in the next session. So in today's session, we'll just have a quick introduction to supervised learning and unsupervised learning. So let's start off with the first one. What exactly is supervised learning? So in supervised learning, we have something known as input variables and output variables. The input variables are denoted with X and the output variables are denoted with Y. And these input variables are also known as the independent variables and the output variables are known as dependent variables. And we try to understand how does the dependent variable change with respect to the independent variable. So here what you see, y is a function of x. So here y would be your dependent variable and x would be your independent variable. And we're trying to determine how would y change if x changes. Or in other words, how is it that x or change in x affecting y? So that's a question from Shobhit. He is asking, what is the scope of machine learning? If you, what you basically mean by the question, if you are basically asking in what domains machine learning is used, then I'd say that machine learning has a lot of different applications across varied industries. Let me start off with, let's say in finance industry. Now, let's say you're just sitting in your home and you suddenly get a message from your bank stating that there has been a transaction on your debit card worth around maybe 2 lakhs in Canada. And but the problem is you've never been to Canada in your life, and the maximum expenditure which you ever do on your card is only up to 10,000. So this comes as a shock to you, and you immediately call up the bank guys and you tell them that this is a fraudulent transaction. But the question over here is, how was the bank able to flag it off that it was actually a fraudulent transaction? So as soon as this transaction occurred in Canada, it immediately flagged off that it was a fraudulent transaction, because what is happening is some sort of machine learning algorithm or some sort of data analysis is being used by this bank. So the bank keeps a check of all of the transactions which are happening, and it goes through all of your transactions. So it understands that you normally have never spent or purchased anything outside of India, and also your purchasing pattern, it's mostly below 10,000 rupees. And suddenly if you go ahead and buy something which is worth 2 lakh rupees, that is a flag. So immediately your bank, it understands that this might be a fraudulent transaction. It sends you a message asking for a confirmation if it is you who has actually perform this transaction. So this is one application in finance industry. Similarly, let's say you have an application of this in telecom industry. Now, especially with a lot of players in the telecom industry, you'd have a lot of customers moving to one company to another company. So this is where this is the typical problem statement known as churn analysis. That is when your customer moves on to your customer, and you basically try to understand how to retain your customer by maybe giving him more offers or giving him more plans, and I basically understand what is it that he desires. And also that be different age groups of customers, you do want to cluster them on the basis of their age groups and understand what age group wants exactly what with respect to your telecom offerings. Vivek Shah Shankar is asking, is it practical session or just a theory? We'll have theory and practical both. So we'll just start off with a quick intro to machine learning, and we'll look at these basic supervised and unsupervised learning techniques, and then we'll have a comprehensive demo where we'll be doing sentiment analysis on the Amazon reviews dataset. So Shobit is asking, can it be applied anywhere in real life? Yes, absolutely. So I've just given you two examples. One example was in the finance industry, another example was in the telecom industry. Similarly, you can use it in even the pharmaceutical industry has a lot of requirement of data scientists and data analysts, and then you got the e-learning industry where you got all of this. Even in the e-commerce industry or even in the entertainment industry, you would need analytics a lot. So if you have seen the movie Moneyball, then you would know that the coach actually recruits players on the basis of data analysis, which is quite interesting, isn't it? So this is what is known as supervised learning, and in supervised learning, again, we will have to, it could be further bifurcated into regression and classification. So we'll start off with classification, and classification is basically the process of predicting the class of a new variable. Now let's understand this with this particular example over here. So since again classification is a supervised learning algorithm, we would have a dependent variable and we will have an independent variable over here. So this what you see, smoking, this will be our independent variable, and whether the person has cancer or not, this will be our dependent variable. And we are trying to understand if a person smokes, then what is the probability of him having cancer, or if the person smokes, whether he will have cancer or not. And as you see, and one thing to be kept in mind is when it comes to classification algorithms, the class, your dependent variable, it has to be categorical in nature, and as you see over here, our dependent variable is categorical in nature over here. So now when I say, we can have two options over here for smoking, either the person smokes or he does not smoke, and depending on either of those, we go ahead and classify the result into either yes or no. And this is the basic idea of classification. So guys, just let me know in the chat if you guys are following me till here, and if there are any doubts or any queries that I can take up. So that was one category of supervised learning algorithm. Now we'll head on to the next category of supervised learning algorithm, which is regression. And as it is stated over here, this method is used to estimate the relationship between different entities. So again, since this is a supervised learning algorithm too, we'll have a dependent variable and we'll have an independent variable. So let's say we've got y is equal to fx over here, and there'll be a very simple example for this. So let's say if you're trying to determine if there's a relationship between the age of the person and the salary of the person, and age over here would be the independent variable and salary would be the dependent variable. So what we'll do is we'll go ahead and map the age onto the x-axis and salary onto the y-axis, and we are basically trying to determine if the salary of the person increases with respect to the age of the person, or is there any sort of linear relationship between the salary and the age of the person. So this is where regression comes in, and when it comes to regression, you would have to keep in mind that the dependent variable should be a continuous numerical. So this should be the basic difference between a linear regression algorithm or a classification algorithm. So in classification, your dependent variable definitely has to be a categorical in nature, and when it comes to regression, especially linear regression, your dependent variable has to be a continuous numerical but to perform the algorithm. Asrar Ahmed is asking how to scrape Amazon reviews, text data. So we had done, if you're talking about how to scrape web data in general, then I had taken a previous live session on web scraping. You can check that out on our YouTube channel. So today's session will not be actually scraping data. We already have the data with us, and all we're going to do is we're going to perform sentiment analysis on top of that data. So that was a quick intro to supervised learning. Now we'll just head on to unsupervised learning over here. And in unsupervised learning, we basically have data which is not labeled. So till now, when it came to supervised learning, we were basically dealing with data which had labels associated with it. Now, over here, let's take this example where we have maybe pictures or collection where we have pictures of cars and bicycles in it. And what we'll do is we will go ahead and build an unsupervised learning algorithm on this data, and this would give us two clusters. The first cluster basically comprises of pictures of all of the cars. The second cluster comprises of pictures of all of the bicycles. Now here an interesting point is, even though there were no class labels associated, the unsupervised learning algorithm was able to segregate this entire data into two clusters. The first clusters had only cars, the second cluster had only bicycles. Now there is one interesting concept over here which is known as high intra-cluster similarity and high inter-cluster dissimilarity. Now when you look at this cluster, you see that all of the data points are very similar to each other. So this is what is known as high intra-cluster similarity. And similarly, if you look at this cluster, all of these data points are very similar. In other words, all of these are just bicycles. So that is why there is high intra-cluster similarity over here as well. But when I compare the data points of cluster 1 and cluster 2, then they are very dissimilar to each other. Because in cluster 1 we've got cars and in cluster 2 we've got bicycles, and this is what is known as high inter-cluster dissimilarity. So the aim of a clustering algorithm should be to have a high intra-cluster similarity and high inter-cluster dissimilarity. And all of this is happening without the data having any labels associated with it. So this is the concept of unsupervised learning. So now that we know the basics of ML, we'll go to sentiment analysis. So sentiment analysis is something where we try to understand the sentiment associated with the data. And sentiment analysis is mostly performed on textual data. Now, for sentiment analysis, you can either use supervised or unsupervised learning algorithms or a combination of both. So in today's session, we'll actually be using the logistic regression algorithm to, let's say what we'll do is we already have the data with us, and on top of that data, we'll try to predict what is the sentiment of it, whether it's a positive sentiment or it's a negative sentiment. So let's just go to Jupyter Notebook right now and perform this analysis. So we would have to start off by importing all of the required libraries. So I mean, in all of these libraries, we would not need all of these. Just that we would, for now, we would need NumPy, Pandas, and logistic regression as of now. The rest of the libraries can be loaded if we want to, let's say, build actually neural networks, and if we actually want to build a complicated neural network and not just a simple ML algorithm. But in today's session, we would want to keep it simple and just build a simple logistic regression algorithm. So the data is present in this file. Actually, I've got two files. One is train.ft.text.bz2. The other is test.ft.text.bz2. So I'll just show you these two files, right? So the Amazon reviews text is basically present in these two files, and these are the extension. What you see, this is basically, these are the compressed files. So I've got the training set of Amazon reviews and I've got the testing set of Amazon reviews. Now, once I have these two, what I have to do is I would have to extract the labels and text out of it. So also these reviews are they are structured in such a way that you actually have a list of text, and in that the first element is actually the label and after that it is the text. So this function, what you see, this seems to be a bit complicated, but let's actually understand what is happening over here. So we are creating a function called as get labels and text, and this takes in an object inside this. Now this function ends over here. This returns labels and text. So let's come down and let's actually see what is happening. So we are using this same method, get labels and text, and first we are passing in the training set inside this method. So when we pass in this training set inside this method, what is going to happen is, so we have sent this file, and then we have initialized two empty lists over here. First list is called labels, second list is called text, and both of these are initially empty. And then we start off a for loop for line and bz2.bz2 file. So this is again a method which is used for extracting data from compressed files. So here we are again passing in the training set over here. Now we are going to decode each line inside this. Now we will have a lot of reviews. So I believe this data set has around 50,000 reviews. So out of those 50,000 reviews, we are going to extract each review line by line. So first I'm going to write line.decode, and the decoding should be of UTF-8, and that line I will go ahead and store it in X. So here again you have to keep in mind that this line has the text along with the labels. So that is why I have created two lists over here called as labels and text. So once I've extracted the entire line, then I would have to basically extract the labels and the text separately. So to this list called labels, I'm going to use the append function. So with the help of append function, I can add something new to the list. So here I'll state labels dot append, and inside this I am passing in integer. So I'm basically this is, so I have got this integer function. So x of 9, this is basically the text, and I'm converting this into integer format. And what is so just what I'm basically doing is I'm extracting the first element, and after that whatever is there from here, whatever occurs after that, that would be the text. So label, I am extracting it and appending it into this labels list. And then whatever text I have, I'll extract all of that text, or basically I'll strip out all of that text and I'll go ahead and append into this text list. So I've got these two lists. So this is my first line. Now I have my first line. What I'm going to do is I'm going to return the label and the text. So here I am converting these labels into an array format, basically a NumPy array. So that is why I'm using np.array over here. And inside this, I will pass in the labels object. So once this is done, I'm going to return these two. Now, with the help of this, I'm just returning the first line. Similarly, let's say if I want to return the labels and the text for the second line. Now this, because of this for loop, we will go ahead and start off with the second line. So again, for line in this will be the second line. We'll extract the entire line, then the second review or the second label will be appended, and then the second let's say the text is also appended to over here. So this is with respect to the training set. Similarly, what we're going to do is we are going to pass in the test.ft.txt.bz2, which will give us test labels and test text. So this is how we are extracting the labels and text for the training set and as well as the test set. Let me see if there are any questions over here. Nagarajan is asking whether sentiment analysis can be applied in chatbots. When you actually talk about chatbots, we have more of NLP applied over here and less of sentiment analysis. Asrar Ahmed is saying, please go step by step in practical. Yes, I'm explaining each line to you guys. If there is any doubt or any query, you guys can go ahead and let me know. Right, so now once I've extracted all of this, what I'm going to do is, so I have all of these different labels and text. So I'm just going to show you guys the first label and the first text. So here, where I given the index 0, this is basically the first label. So this is the first line which I've extracted, and the label seems to be 1. So here, if it is 1, this means that it is actually the sentiment of the review is actually positive. And let's actually see what is the review over here. So train text, you see how the review is stunning. Even for the non-programmer, this soundtrack was beautiful. It paints the scenery in your mind so well. I'd recommend it to even the people who hate video. I have played the game Chrono Cross, but of all the games I've ever played, it has the best music. So you have a lot of positive vibe over here, and you see that is why the label for this is 1. So 1 over here basically means that this is a positive review. Now since we have to apply the logistic regression algorithm on top of all of this, what we're going to do is, since we have 50,000 reviews in total, out of the 50,000 reviews, we are going to extract only the first 500 reviews. Now, to extract only the first 500 reviews in this list, what I'm going to do is, so let's say the first 500 labels. So from train labels, I am extracting only the first 500. So here the list number starts at 0 and goes on till 500, and I'll go ahead and store it in train labels object. Similarly, over here I've got train text. So this is how I'm extracting the first 500 reviews, and I'm storing it in train text. Now, once this is done, what I'll do is, this would need some sort of pre-processing. So in that pre-processing, what I'm doing is I am converting all of the text from capital case to small case, and wherever I have any special characters or maybe any punctuation marks, I'll go ahead and I'll remove all of them. So if you see this particular text over here, you see that some of the text is, you've got capital T over here, you've got capital S over here. So this basically means that we've got some characters which are in capital keys, and then we've also got these punctuation marks, we've got this explanation mark, and we've got these special characters. Now I'd want to go ahead and remove all of these special characters from the code. So this is where I'm doing the basic text pre-processing, and for that I would need the RE library. So RE is mostly used to work with regular expressions, and I'm going to go ahead and import that library. Once I go ahead, I'm going to create two new objects called as non-alpha num and non-ASCII. So here, when I use this method called re.compile, and inside this I'm basically passing in backward slash and capital W. This would basically mean that I am so basically wherever the characters are non-alphanumeric and they are capital, I would want all of them, and that has to be extracted. So that particular part I'm storing it in non-alpha m. Similarly, I'm going to create another regular expression method. So here I'm going to type re.compile, and inside this I've got small characters A to Z, and I've also got the punctuation marks and the numbers over here. So that part I'm going to store in non-ASCII. Now once this is done, I'm going to create another method called as normalized text, and inside normalized text I will be passing an object. Now here come down over here. So here this is where we are actually invoking the method. So we've got normalized text, and first we'll be passing the train text. So this is the train text which we had created, the shorter version, and this is what we are passing over here. When we pass in train text inside this method, so we have another list over here called as normalized list, and this is an empty list over here, and then we'll start a for loop. So for text in text, so here we will have the first let's say first review, and that first review, what we're going to do is, the first task is to convert the entire review into lowercase. Once we convert the entire review into lowercase, then we will go ahead and what we'll do is, wherever there are alphanumeric characters, we are going to substitute that alphanumeric characters, or sorry, wherever we have non-alphanumeric characters, we are going to go ahead and substitute those non-alphanumeric characters with a space, because we don't want the special characters. Similarly, where we have non-ASCII characters, we will go ahead and substitute those non-ASCII characters with this is just blank over here, or we can even give a space. So this is what we are doing. Wherever we have special characters, non-ASCII characters, non-alphanumeric characters, we will go ahead and substitute them with this sub method, and we are just substituting it with a blank space, or we'll just remove that out by just giving it a single quote over here. Now once that is done, we'll just go ahead and so we have this empty list over here, and we are appending this no non-ASCII. This would mean that no non-ASCII basically does not have the non-alphanumeric characters, and it also does not have the no ASCII non-ASCII characters. And we'll just go ahead and return the modified list. Now in that, similarly, we will do the process for train text and test text as well. And now once we come down, as you see, so this is the same review. So this is what we had initially, and you see over here that we had some capital cases, we had these punctuation marks, we had these special characters, but when you come down, you will see that all of these characters have been removed and the capital case has been converted to smaller case. So this is the basic text pre-processing which we have performed over here. And once that is done, now to actually build the model and actually to predict on the test set, what we have to do is we would have to convert this text into numeric characters. Because if we have to build a machine learning algorithm, or maybe if you have to build an NLP model, then that NLP model or maybe the sentiment analysis model, it will not understand your textual data. So to understand that textual data, we would have to convert that text into something known as a count vector. So we have this method called as count vectorizer, and we're going to import this from sklearn.featureextraction.text, and we will just import count vectorizer. And once we import that, we will create a new object out of this. So count vectorizer binary is equal to true. So when I say binary is equal to true, so for this entire text, we are just going to have two values, either 0, 1, 1, and we will store that into a new object called CV. Now here, once that is done, we are going to go ahead and fit this count vectorizer on top of the training text, and then we will go ahead and transform the training text and the testing set. So the transformed training text is stored in capital X, and the transformed testing text is stored in the capital X test. So you can basically understand. So in the if you want to understand how it is happening in the background, what is basically happening is, let's say you have a repository over there, and for that repository you will basically have either 1 or 0 marked. So let's say you have a repository of all of the words, and so we have this particular sentence over here, and let's see if there is stunning occurring 2 times, you will have the label and you will have the number of times this word occurs. Similarly, you have I over here, then you will have the label and you will have the number of times this particular letter occurs. Similarly, you have it, so we'll have this label and number of times this word occurs. So this is how count vectorizer works. Now once we have converted this into basically a numeric format, we can go ahead and actually build our logistic regression model on top of this. So this is how our X test actually looks like. So if we have to build the logistic regression model, we'd have to import this. So we will just type from sklearn.linear model, we'll type in logistic regression, and after that we also want to see the model which we've built, what is the accuracy of it. And before we actually build the model, we would have to divide our data into training and testing set. So now here, to divide the data into training and testing set, we'll be using train test split method, and inside this we are passing in the let's say your training set and your basically your independent variables and dependent variables. Your independent variables are basically this, which is X. Your independent variables are train labels, and then you set a train size of 0.75. This would mean that 75% of your data would go into the training set, and the rest 25% of the data would go into the test set. So now that we have divided the data into training and testing set, we will start off with a for loop. And over here we have different C values. So the different C values are 0.01, 0.05, 0.25, 0.5 and 1. Now what exactly is a C value? The C value basically means by how much do we want to regularize the data or the model, how much do we want to regularize the model onto the data. So this factor determines it. So this is basically known as the inverse strength of regularization. And as the value of C increases, you would see that the regularization also increases. So first, in this for loop, we are building a logistic regression model with the C value to be is equal to 0.01. And once we create an instance of this logistic regression model, we're going to fit this on top of the train set. So we are just typing in lr.fit and we'll pass an x train and y train. And once we fit this model, we are going to check the accuracy on top of the validation set over here. So as you see, for different C values, as the C values are increasing from 0.01 to 1, the accuracy is increasing on top of the the accuracy is increasing as we increase the amount of regularization. And we see that when the C value is 1, we will have the maximum accuracy on top of the validation data set. And that's why we'll just take the value of C to be perfect. Now, once that is there, we have fit the model on top of the training set. We are going to go ahead and predict the values on top of the test set. So here we will use lr.predict, and let's say we have if we want to predict on the 29th review, so we'll just use x test 29 and when we do this, we get the result of 0. And if we actually check the label, so these are the actual values, these are the predicted values, or you can call this the observed value and this as the predicted value. And as you see, the observed value and the predicted value are also quite correct. So it seems that this model which you built does decent enough. And let's actually look at the review. So this is the actual review. 3 days of use and it broke. Very disappointed in this product. It worked perfectly for exactly 3 days and could not be resuscitated. It was very inexpensive, so I did not want to pay half again the price to ship it back for an exchange. So the company would do nothing when they send me an industry as to product satisfaction. So this actually is a negative review. And the actual value was 0 and the predicted value is also 0. So this is a simple sentiment analysis on Amazon reviews. Now, if you want a better model, you can actually go ahead and build a neural network model. Maybe you can go ahead and build a CNN or an RNN on top of this, or maybe you can go ahead and build a decision tree or a random forest or other classifiers such as NIBase, KNN and SVM on top of this. So that would basically help you to understand which model would be perfect fit on this data. So for today's session, we have done a basic text pre-processing and then we've just built a simple logistic regression algorithm and we've seen how the result works over here. Nagarjun is asking, please show the code which is establishing the connection with Amazon services. So this is actually a dataset which I have downloaded. So I have downloaded this Amazon reviews data from Kaggle. So you guys can go ahead and check out the data from Kaggle itself. Shobit is asking, if we get a poor service from any airline service and I sarcastically tweet it, what a great service you guys provided. Really not going to suggest anyone. So what is going to happen is, let's say if your sentence is structured into two parts, where you have in the first part you have a positive connotation, in the second part we have a negative connotation. I'll take both of those because NLP can't really understand sarcasm in general. So it will maybe so as you have stated in the sentence, the first part of the sentence is positive and the second part of the sentence is negative. So you will have a rating. So let's say for every negative word you will have a rating of -1 and for every positive word you will have a rating of +1. And if you add all of those, if let's say the entire rating becomes 0, then the final outcome would be neutral. So this is how sentiment analysis actually occurs. So every word, or maybe you basically have a dictionary of positive words and you have a dictionary of negative words, and in every sentence that you encounter, you basically the sentiment analysis of whatever algorithm there is, it counts the number of positive words and the number of negative words, and it adds a +1 for every positive word and a -1 for every negative word, and then it does the total. So if the total is less than 0, then you'll get a negative class, and if the total is greater than 0, then you'll have a positive class. If it is exactly 0, then the review will be neutral. Parth is saying it will be better if I add comments in the code file. Yes, I'll do that. Right, so I guess we are done with today's session. So if you have any more questions, you can add it over here. Saurabh is asking, what if my data is discrete? So what exactly do you mean by that? If the text is discrete? So Shobit is asking, is there any way we can include these sarcastic reviews? So here, when you talk about understanding sarcasm, then we would have to use RNNs in this case. Now, what happens in RNNs is there is a special type of RNN called as LSTM, which is a long short-term network, and the long short-term network is available, that is capable to understand what has actually happened in the past, or it has the ability to remember what has happened in the past, and you would have to train this LSTM a lot on the base. So you'd have to basically feed it a lot of sentences which are sarcastic. So let's say um, this sentence such as maybe you're so tall that even Lilliput would be taller than you. So the first sentence, you're so tall, seems to be positive. The second sentence, that even Lilliput is taller than you, that basically has a negative connotation. So you'll have a lot of such sentences. Maybe you'll have a repository of a million sentences, and you'll feed all of these sentences to this LSTM algorithm. And what it does is it tries to identify patterns. So let's say here, at some point, at maybe at the midway or maybe at the quarter, there is a turning point over there. So it looks for words. So it looks for words such as but or also, or so let's say if it encounters the word but, then it would know that there is some sort of sarcasm involved. You're so tall, but even Lilliput would be taller than you. So the first half seems to be positive, but the second half is not really positive. So you'd have to feed these sort of sentences so that the neural network actually understands about sarcasm. Sneha is asking, what if I have text data in one of the feature in data set along with other features, how to deal with it? Um, could you elaborate it a bit more, Sneha? So what do you mean when you say if I have a feature along with other features? Shobhit, so we would have certain courses on AI and neural networks just with respect to sentiment analysis. Not really sure, but you can just go ahead and check out on Great Learning Academy if you're able to find this. So Niranjan, we have not yet uploaded the Python notebook on GL Academy. We'll upload it soon. So maybe in a couple of hours or maybe in a day or two, you can find this code file over there. Shank is again asking, can I please share the notebook? So this dataset will be available. I mean, as of now, it's not uploaded, but we'll upload it on JLA for sure. So guys, if I guess I can go ahead and end the session for today. So thank you very much for attending, and hope you guys have liked the session. So also for the folks who don't know what GLE is, go ahead and check out Great Learning Academy, where we have close to 100 courses with respect to data science, AI, cloud computing, digital marketing, and stats. And once you complete these courses, you will have a course completion certificate, which you can go ahead and add it in your resume. So, guys, thank you very much, and let's go ahead and meet in the next live session.